Hello, good morning, everyone. Hope you are doing well. So, last week we started our lesson, data analytics, and we discussed some of the fundamental concepts of data analytics. Do you have any concerns regarding our previous lesson?
No, sir, everything is fine.
Okay. So, let's continue then. We identified data as the most important asset in modern world. That's why we call data is the new new oil. Data on its own does not have a meaning, right? So uh, the processing, the processing and the analyzing of that data make them into information, right? After processing that data, they will become information. Using that information, we can make uh, decisions or we can derive insights, right? So on its own, data does not have a meaning, but we can process data. After processing that data, they become information. Using that information, we can derive insights from the data, right? So, so data analysis is the process of is a process of inspecting, cleaning, and transforming the data into useful information. So, data analysis is the process of transforming that data into something meaningful, right? Uh, as Professor Atif Milan described, we have produced more data in the last 2 years than all of human history, right? All of human history combined. So the future belongs to those who can analyze this data intelligently. So this emphasizes the value that the importance of data analysis, right? And we discuss data analysis is a part of the broader field of data science. So, which is a scientific discipline about data. Uh, and data scientists or data analysts are the persons or the professionals who analyze large data sets and apply data science techniques to extract actionable insights. Right. So today we will discuss about statistics. Today we will discuss about statistics. So, uh, what do you know about statistics?
It's divided into two. First one is descriptive analysis and inferential analysis.
Yes, yes. Statistics is a branch of mathematics. Statistics is a branch of mathematics that concerns about data. Why we need statistics for data science, right? As this person, Josh Wills, says, a data scientist is someone who is better at statistics than any software engineer and better at software engineering than any statistician. So that means basically you need to know both programming and some sort of statistics, right? Uh, in data analytics, we use statistics to turn raw numbers into useful insights. So statistics is a branch of mathematics that concerns with the collection, organization, analyzing, interpretation, and presentation of data. Statistic is a vast field. Statistics is a vast field, right? So, uh, and statistics is used in almost every field, like businesses, sports, health, politics, technology. Likewise, data science is one such field, and um, in data analysis, we don't need to know all the statistics, right? We don't need to know all the statistics, but uh, rather we need to focus on the parts that helps us analyze data and find patterns, specifically on statistical methods, concepts that support data analysis and uncover patterns and enable data-driven decision making, right? So we need to know about descriptive statistics, inferential statistics, probability distributions, and sampling methods, regression analysis, hypothesis testing, data visualization, some sort of testings like ANOVA, time series. So these are the things we are going to focus. Basically, we can divide statistics into two: descriptive statistics and inferential statistics. Descriptive statistics is about summarizing and and describing key features of a data set. So descriptive statistics focus is on what this data tells us. Then we have inferential statistics. So inferential statistics is about making predictions. Predictions. We have a large data set. From that, we take a sample. Using this sample, we try to make predictions about this large data set, or we call this the population. Population. From this population, we take a sample, and with this, using this sample, we try to make a prediction about the population. First, we will focus on descriptive statistics. Descriptive statistics are used to summarize, organize, and describe key features of a data set. So what are these key features? The key features are measures of central tendency, and measures of variability. So the central tendency tells us where most of the data points are gathered. There are three measures of central tendency: mean, median, and mode. So mean is basically the average. Mean is basically the average of the data set. And median is the median means after arranging our data set in ascending or descending order, what is the middle value? After arranging the data set in a ascending or descending order, what is the middle value? And mode is the value which occurs most frequently. So mode means the value which occurs most frequently. Let's take a simple data set. So can you calculate the mean of this data set? Mean is the average, right? Average, right? So x bar is equal to sigma x divided by n.
We have to arrange
It in
by ascending order.
ascending or descending order, right? So median. Then we need to find the middle value.
8, 10.
7, 8, 10. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 elements, right? That means our number of elements are, let's say n, this is even number. Here there are two middle values. 4 and 5 are both are the middle values. So we can get it by n divided by 2 term plus n divided by 2 plus 1th term divided by 2. Then calculate the mod. Mod means the value which occurs most frequently. There are two values, right? 2 and 4. Right? These two occur 2 times. So we can consider 2 and 4 as
Sorry,
our mod.
2 and 4.
Yeah, 2 and 4 is our mod. Right? So that are the measures of central tendencies. So then let's move to measures of variability or the dispersion. Right? So variability refers to how much the data points differ from each other and from the central value, right? So measures of variability or the dispersion means how much the data points differ from each other and from the central value. So you can see there are two data sets, right? So one is more centralized to the mean, right? So most of the data points are gathered around the central point, that is mean, right? Center value, right? Then the second value is, in the second data set, there is a dispersion, or the data points are scattered, right? Data points are scattered. So in measures of variability, we try to identify how much our data set is differ from each other or differ from the central value. If the variability is low, variability or the scatterness is low, data points are gathered towards the data points are more closer to the center, close to the center. And if the variability is higher, the data points are spread widely, right? They are not close to the mean. They are not close to the mean. Not close to the mean, right? So why this understanding is necessary? Why this understanding is necessary? So as an example, imagine we have two classes. Example, we have two classes. Right? Let's say we have 100 students, 100 students in both classes, right? One class has 100 students and other class has 100 students, right? Then when we calculate the mean, both says it's 75. Both says it's 75, right? But in this first class, there are many students whose values are between 50, 40 and 50, 40 and 50. And there are many students whose values are between 90 to 100, right? Right? But when we calculate the mean, it says 75, right? And in this class, we have many students whose values is between 70 to 80. There are very less amount of students whose values are below 40, and there are very less amount of students whose values are above 90, right? So you can see, even though in both classes, the average or the mean is 75, we can't get a clear idea about students' performance, right? So here there are very smart students and the students with very low performance. And here in this class, most of the students' performance is average, right? They have average performance, but the mean of the both classes is 75. So that's why we need this understanding, the measure of variability. So there are three measures of variability or the dispersion. First one is range, then variance, and third one is standard deviation, right? So the range is the difference between the largest and the smallest value in the data set. The difference between the largest and the smallest value in the data set, right? So R is denoted by H minus L, highest value minus the lowest value, that is range, right? Then the variance measures data sets spread or the dispersion. We denote it as S square for the sample variance or sigma square for the population variance. Then we have the standard deviation. Standard deviation is the square root of the variance. Benazi, can you calculate these three things?
Yes, me, sir. Can I answer?
Yes.
Range is highest value minus lowest value. So 10 minus 5 is equal to 5.
Yes.
So range is 5. And the second one, variance, is wait, sir, I'm calculating.
5, right? So we have 4 points. 18 divided by 4. That means what? 4.5, ne? 4.5. Harada?
Yes,
4.5.
sir.
Okay. Then standard deviation is basically the square root of the variance, S square. So that means square root of 4.5. Right? Tell us.
2.1.
So that close to 2.12, right? Quartile ranges. Quartile range means, you can remember, we calculate the range. Range means the highest value minus the lowest value, right? So we divide this range into 4, right? We divide this range into 4, right? First 25, the second 25, third 25%, and the fourth 25%. And the middle value we call the Q2. Q2 is what? Q2 is then the median. So overall, you can see 25% of data below first quartile and 50% of data below second quartile and 75% of data below third quartile. So first we need to we have the first quartile, second quartile, and the third quartile. First quartile means, let's say, if our numbers are odd, n is odd, right? Right? We need to divide it into 4. N plus 1 divided by 4. Q2 n plus 1 divided by 2. Or rather, we can say n plus 1 divided by 4 2 times. Or Q3 means n plus 1 divided by 2 divided by 4 3 times. Right. Inferential statistic is making predictions about the population based on the sample of data taken from the population. So we had the population. We use some sort of a sampling method to take a sample, and we try to make predictions about the population. To understand, here the sampling technique is very important, right? Because, why? Because our sample should sufficiently represent the population. Say, let's say as an example, I want to, what is the passing percentage of, O-levels in Sri Lanka, right? So what is my population?
Students of ordinary level, no?
Yeah, all the students who faced O-level exams, right? From that sample, for that prediction, I'm taking a sample. Let's say I'm taking a sample from the populous schools in Sri Lanka. Like,
I can't understand, sir. Without calculating, how can we say?
no. This is a hypothetical example, right? So we have O-level exam. I want to get the passing rate. So what is the passing percentage? So I can't measure all the students in Sri Lanka. So therefore, I will take a sample. Using statistical method. We can analyze the sample and make predictions about the population. That's what we are trying to do, right? So therefore, I need to take a sample. So I am taking a sample from students who are in Colombo district. Then I will analyze that data and say, okay, the passing percentage is 100%. Is that correct? No, right? Because my sample does not sufficiently represent the entire population. So if I want to take a sample that sufficiently represent the population, I need to take students from a sample from all Sri Lanka, right? Covering from north to south.
Whole island.
Yeah, not all the students, but a sample that sufficiently represent the population, right? So therefore, that's why we have sampling techniques. And inferential statistics is,
Yeah. Excuse me, sir. It means it's hypothetical, no?
yeah. Sorry.
Mm. Uh, I mean, I'm asking. It's hypothetical, no? Not the accurate one.
Yeah.
Okay.
That's why we
Okay.
use statistics, right? In it's hypothetical. Like we can't measure the actual like the population's exact value. It's impossible, right? In that kind of scenario, we take a sample and we analyze that sample and we make predictions about the population, right? So when our sample gets larger and when the sample sufficiently represents the population, the accuracy is higher, right? That's why we use
Yes.
statistical techniques. That's the purpose of using statistics.
Got it.
Yeah. So that's the idea. So that's why uh, inferential statistics mainly associate with hypothesis testing. So basically, in hypothesis testing, what we do is we make a hypothesis. We make a hypothesis, state a hypothesis, and uh, uh, we will define a null hypothesis and the uh, alternative hypothesis n0 and let's say h0 and h1. Then we will determine a significance level. Then uh, we will calculate, we will take a sample and we analyze that sample and from we analyze that sample, we basically calculate the p-value and based on the p-value, we say our hypothesis is accurate or rejected. Hypothesis got accepted or rejected. So I will explain this deeply. So before, from this, I will move to this sampling techniques. We have mainly two sampling techniques, probability sampling and non-probability sampling. Right? Probability sampling and non-probability sampling. Right? So we will understand what is this probability first. What is probability? Probability means the measure of how likely an event is to happen. How likely an event is to happen. Let's say I'm tossing a coin, right? Tossing a coin. So what is the probability of getting head? Probability කියන්නේ යම්කිසි දෙයක් වීමේ සම්භාවිතාව. යම්කිසි දෙයක් වීමේ සම්භාවිතාව. එතකොට මම උදාහරණයක් විදිහට ගන්න මම කාසියක් උඩ දානවා. කාසියක් උඩ දානවා. හෙඩ් වැටීමේ සම්භාවිතාව මොකක්ද? සිරස වැටීමේ සම්භාවිතාව. කාසිය බයස් නැහැ කියලා හිතුවොත් බයස් කාසියක් නෙමෙයි. මම එයා උඩ දානවා. එතකොට සිරස වැටීමේ සම්භාවිතාව කීයද? අවස්ථා දෙකයිනේ තියෙන්නේ. එක්කෝ හෙඩ් වෙන්න පුළුවන්, එක්කෝ ටේල් වෙන්න පුළුවන්. එහෙමනම් හෙඩ් වීමේ සම්භාවිතාව 50%යි නේද? 50%, right? So, right? So probability range between 0 and 1. 0 and 1. So, probability කියන්නේ number of favorable outcomes divided by total number of outcomes. So,
It's one, no?
yeah, getting head is number
1/2. Total
1.
number of.
Yeah, number of favorable outcomes. I want to get H and I have 2 total outcomes. That means 0.5.
Right.
So why probability need in statistics? Why probability need in statistics? Sorry, probability need in data analysis. So our subject is data analysis. Probability is basically the likelihood of an event happen. So in other words, it allows us to make predictions. It allows us to make predictions, and like it's using in machine learning. Basically, it's using basically it's a part. It's heavily using in machine learning, because in machine learning also we try to make a prediction, right? So the answer he gives us is a prediction. Like machine learning, we have two things, right? We a training data set and a test data set. So using our training data set, we train the machine, the algorithm, right? Then when we input test data, based on the trained data, he will make a prediction, right? So that's based on the probability. In probability, we have some terms. First thing is sample space. Sample space. Sample space means all possible outcomes. All possible outcomes. Sample point. Sample point. Sample point is one possible one one possible result one possible result, right? Experiment means, then we have the term as experiment. Experiment is the, let's say, is the we can say it's the process, right? It's the process, and we can say event is the uh, subset of the subset of sample space. Then the favorable outcome means our desired outcome, right? That is favorable outcome. So sample space, sample point, experiment, event, favorable outcome. So let's take an example, and I didn't understand. Example is you are rolling a dice, right? You are rolling a dice. So what is our sample space? Sample space is all possible outcomes. So 1, 2, 3, 4, 5, 6, right? I am rolling a dice one time, right? One time. Uh, that's uh, that's my experiment. Experiment is the process, right? I'm rolling a dice one time. That's my experiment. Rolling a dice one time. That's my experiment. For that experiment, sample space is the possible outcomes 1, 2, 3, 4, 5, 6, right? Then we have a sample point. Sample point means one possible outcome. So we can say 1, 2, 3, 4, 5, 6, right? Those are all sample points, one possible outcome, right? Then uh, event means, let's say, after rolling the dice, I get 1 as the output. That's the event. from these possible outcomes, after rolling the die, I get 1. So that is the event, right? So event is a subset of the sample space. Sample space can all possible outcomes. Sample point කියන්නේ one possible outcome. කියන්නේ වෙන්න පුළුවන් එක දෙයක්. Then event happen. Event අපි හිතමු die එක roll කරාට පස්සේ dice එක roll කරාට පස්සේ අපිට එක හම්බ වෙනවා. That is the event. So event is a subset of sample space. Then our favorable outcome. We have the favorable outcome. Favorable outcome, let's say our favorable outcome was 2. But I got 1, right? So what is the probability of this favorable outcome? It's 1 divided by 6, right? 0. Random variable is a numeric value that represents the outcome of a random process or an experiment. Numeric value that represents the outcome of a random process or an outcome, right? So in our example, we roll a dice, right? So then our outcomes are 1, 2, 3, 4, 5, 6, 7. So this is a random variable. A random variable is a numeric value that represents the outcome of a random process or a, right? So this random variable's value can be discrete or continuous. Discrete or continuous. In data analytics, let's say we have an Excel sheet. Each of these, the value from this Excel sheet can be considered as a random variable. Random variable. Let's say age. So we have 10 students. So one's age is different from the other. So each record represents a unique record. So this value we can consider as a random variable, right? So we can you apply statistical concepts because these are random variables. Random variables. It's a mathematical rule for inverting conditional probabilities. Conditional probabilities. What is the probability of A of given that B happen? And B උනාට පස්සේ A වීමේ සම්භාවිතාවය. Right? So we can calculate it by this formula. Probability of A given that B occurred is equal to probability of B given that A occurred multiplied by probability of A divided by probability of B. So let's take an example and understand this concept. A certain disease affects 1% of the population. A certain disease affects 1% of the population. A medical test is developed to detect this disease. If a person has the disease, the test returns positive with a probability of 99%, which we call true positive range. The patient has the disease and the test says it's positive, right? Then if a person does not have the disease, the test still returns positive with a probability of 5%. We call that false positive rate, right? So the person actually does not have the disease, but the test says the person has the disease. right? So if a person, then if a person tests positive, what is the probability that they actually have the disease? So now the test says the person tests positive. What is the probability they actually have the disease, right? So let's take A, the event A. Okay. Let's take A as event A as the person, the person has the disease. Then let's take the event B as the person test positive, right? So we have this data, right? If a person has the disease, the test result positive with the probability of 99%, right? So that means B, the person test positive given that the person has disease, 99%. If a person does not have the disease, the test still returns positive with the probability of 5%. If person does not have A, still the person can test positive. The percentage is 5%. Right. What I want to calculate is probability of having the disease given that test is positive. My equation is probability of B by A multiplied by A by probability of B. We says the certain disease affect 1% of the population. 1% of the population. So the probability of having the disease is 1%. That says probability of having the disease is 1%. So PA is 1%. So then probability of not having the disease is, probability of not having the disease is 99%, right? Then probability of person test positive given that person actually have the disease is 99%. Probability of person test positive given that even if the person does not have the disease is 5%, right? Right. So this is what we need to calculate. So we know this, and we need to find this probability of B. The person can be test positive with two things. If the person has disease plus if the person does not have disease. The answer will be like 0.5, 0.0594, 0.94. Then we can calculate this. We can calculate probability of A, that means probability of actually having the disease given that the test positive. So next week I will discuss with you about this probability distributions and sampling techniques and statistical methods like regression, hypothesis testing, a concept like covariance and correlation. Right. So basically today we discussed first we started discussing about statistics. Statistics is a branch of mathematics that deals with analyzing and interpreting data, right? So it has two branches, uh, descriptive statistics and inferential statistics. Descriptive statistic is basically describing the data, right? So there we had two things, one central measure of central tendency and measures of variance. Measures of central tendency was mean, median, mode. Then we had the variance. Variance means how much data spread from the center, right? So there we had the range, variance, and the standard deviation, right? Then we came to the inferential statistics. It's about making predictions about the population. Because we can't uh, observe the entire population, we take a sample from that population, right? So that sample, we can't just take a sample, we have to use a statistical method because otherwise our sample will not sufficiently represent the entire population, right? So therefore, we have to use sampling techniques. So we will discuss those things. Then after taking the sample, we can do the analysis. So we let's say sample mean. So from that sample mean, we try to estimate the population mean. So that's what we are trying to do. So inferential statistics is about making predictions, or you can see it's hypothetical. So it's about it's closely linked with hypothesis testing. Hypothesis testing. So that's our objective. So we make a hypothesis and we take a sample and we do data analysis to prove that hypothesis. So that's what as data analysis we do, right? Right. So then we need to discuss about probability. Probability is the percentage or the likelihood for an event to happen, right? Event to happen. So then we discuss about Bayes theorem, which is conditional probability. So what is the probability of A happen given that B already happened? Right? After B happened, what is the probability of A happening? Like that. So that's what we discussed today.
Yes, sir. I got it everything.
Right. So let's stop for today. Yeah. Have a nice day then.